Hey class, how's it going? We got video two here. I'm actually going to be looking at some of the actual gravitational questions now from our practice sheet. So this video is going to focus on trying to find the actual gravitational force between the two objects, so kind of like the gravitational field force between two objects. The next video, the last video that I'm going to make, is going to look at, now that I have that force, how do I get the actual object's velocity, acceleration, all that kind of stuff. So let's look at trying to figure out, use this formula really well to figure out that actual force gravity, or also force like the circular force, keeping it in that actual orbit. So let's think of, starting with this one, we have question 1 from our actual gravitational orbit question. It says an 8 kilogram ball is separated from a 6 kilogram ball. So I have big M, 8 kilograms, little m, 6 kilograms. If you just want to put M1, M2, that's fine as well. And the radius is 2 meters apart. Okay? What is the gravitational force between them? So let's actually find the gravitational force between them. It's going to be very small, okay? Because when you think of, like, again, I'm being pulled down at so many newtons with a massive Earth, these are two balls that are very, very small. So you should get a really small answer here. Let's see what we get. So force gravity equals big G, okay, in brackets, M over radius squared. Okay, so I have 6.67 times 10 to the negative 11, in brackets, 8 times 6 divided by 2 squared. Okay, this is going to give me, I'm just going to do this little bracket for us here. 8 times 4 is 36 divided by 4, I believe then gives me, okay, let's do this my guy. I didn't write it down nicely enough. 8 times 6, this should be 6, my bad. 8 times 6 should give us 48. Divided by 4, I should get 12. Okay, so this whole thing comes out to 12. Okay, so now I have 6.67 times 10 to the negative 11 times 12. Well, how do I do this? Just go 6.67 times 12. We'll leave this alone for now, and then we'll kind of recalculate it using scientific notation after. So 6.67 times 12 gives me 80. 80 times 10 to the negative 11. Okay, newtons. Okay, so that is like basically 80, and then move the decimal point over 11 spots. So you're gonna have like 0.00009 zeros, and then 80. If I want to write this in proper scientific notation, I'm going to make sure it's 8.0 times 10 to the negative 10. Okay, in the sense of like I had a bigger number. Okay, so that this needs to get smaller. I would accept either answer. This is definitely more correct, and I know in university they only take this. This is a wrong answer because scientification. This is the right answer, but they're the same value, okay? So if you were to write this out, like even more technically non-scientific wise, I'd go 0.1, 2, 3, 4, 5, 6, 7, 8, 9, within 8 newtons. That's how much force they put on each other. Not a lot, okay? Which makes sense. They're two very small objects. Oi, question 2. Question 2. It says 2 satellites of equal mass. Okay, so technically M equals the other M right now. Okay, they're put 30 meters apart. So radius is 30, and there's a gravitational force of 2 times 10 to the 7. So force gravity equals 2 times 10 to the 7. Okay. What is the mass of each satellite? Well, let's set this up. Okay, force gravity equals big G M over radius squared. The nice thing is, if these two are technically the same mass, I can combine them to make like mass squared. Okay, because I care about these two satellites and what kind of gravitational pull they have on each other. So if they're actually the exact same mass, I can make it m squared, which enables me to actually make this question. Now I can solve this question. I have 2 times 10 to the 7 equals 6.67 times 10 to the negative 11, and then m squared over 30 squared. 30 squared I'm going to change right now to 900. 30 squared is 900. Okay. Over 900. So I have to move this over first. Right now this is multiplying by this, so I'm going to divide it. Okay, so I divide this 6.67 times 10 to the negative 11. All right, let's do that. Let's go. 2 divided by 6.67. I get 0.299. Okay, so I'm going to get 0.299. Now, if I subtract these, okay, if I go 7, and please, this happens all the time, Please don't go 7 minus 11. This is 7 minus negative 11, okay? So 7 minus negative 11, which means this kind of becomes a plus. Okay, so I'm going to have power of 18. Think of this as a very, very, very small number. When you divide by a very, very small number, this number gets way bigger. Okay, if I go 2 divided by 0.5, I get 4. If I go 2 divided by 0.001, I get like 200. Okay, so this is a very small number, so this will get big. So, to the power of 18 equals these two, m squared over 900. Times by 900 to move it over. So we're going to times by 900. Okay, alright, so 0.299 times 900 gives me 269.1. So this now gives me 269.1 to the power of 18 equals m squared. So this is the one time where you actually have to put all the zeros in to actually square root it. Because there's not too many calculators that are going to be able to go like to the power of 18 and square root it. So if I actually go 269 and then just basically put zeros behind it, okay? 18 in 1, 2, 3, 4, 5. Oh, I forgot to put square root. Haha. Square root. 2, 6, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 equals. And I get 1.64 to the power of 10. Oh, something went wrong. Why did something go wrong? Don't know. Oh, this is negative 7. Okay, I found a mistake, which is really, really good here. Okay, this should be negative 7. That is negative 7. Okay, if I go look over here, it's negative 7. That is a good thing to have, okay? So, I haven't done anything wrong here. Unfortunately, I've left out a negative 7. My work got in the way here. This is a negative 7, which means this is a negative 7, which means I have this. Negative 7, okay, minus negative 11, which means I'm going to get 4, okay? So instead of the power of 18, I have the power of 4, which means this is still the power of 4. Okay? So 269 times 10 to the power of 4. Okay, way better, makes way more sense. Square root it, and then when you do that, so I will get an answer that is equal to 1,643, okay, kilograms. So that is my actual mass for the two satellites, 1,643. Okay, the next video I'm going to kind of do a bigger version where I'm talking about the Earth and that kind of stuff. We're really going to focus on some scientific notation, as well as we're going to incorporate some of that velocity and acceleration. All right, class, thanks so much. I'll talk to you soon.